morning, everyone. Welcome to AusCERT 2020 Day 2. So for those of you who weren't here yesterday, my name is John, and I'll be hosting String 4 for the rest of the day. Before we get started with our first speaker, I just wanted to get through some housekeeping things. So if you guys are using any browser, try to use Chrome, and if anything crashes, just refresh the browser and it should be good to go. Don't have too many tabs open at the same time. We have some Q&A functionality on that right-hand panel there that you can see. So if you have any questions, just put it there, and I think people have the ability to vote it up, which is good. There's also a raise hand function at the bottom of your screen. So if you want to ask a question live or have any issues, just hit that, and one of the guys will get to you as soon as they can. And if you guys want to go back to the foyer during the presentation, the link is in the general chat window there. So our first speaker for today is Ronald Michael from Synopsys. So Ronald is a senior application engineer within their software integrity group, and he specializes in DevOps automation and cloud security. So his topic will be a modern approach to application security testing. So yeah, go ahead, Ronald.
Good morning to all the listeners today. My name is Ronald Michael, and I'm a Senior Application Security Engineer with Synopsys. I hope you are staying healthy and safe during these unprecedented times. Although it's exciting to be a part of this new virtual format. Most of us entered 2020 expecting a very different reality than the one we currently live in. But what's great to see is how we are navigating and adapting to this new world. Speaking of new, the presentation I have for you is going to touch on a new innovative technology in the application security space. I would like to thank you for joining, and I hope I can add value to you in this session. So let's get started. Here's the agenda for this session. You'll get a background of why would any organization consider IAST in the first place by understanding the latest application security trends. Then we will see what IAST is all about and dive deeper into the inner workings of IAST and its different flavors, and try to make sense on how it fits into the DevSecOps environment. Finally, we will look at in what cases it makes sense to use IAST for different organizational needs. So before we jump into the main topic, let's try and understand the need for application security testing and focus on what's the problem in application security and why would organizations care about this. Most organizations are looking to adopt some level of DevSecOps practices into their development process for reasons of improved speed, cost, better development flow, and improved quality through continuous feedback. This is especially true for organizations building web-based applications. Gartner predicts 60% DevSecOps adoption by 2021, and you don't want to be left behind. The problem is that this move towards DevSecOps practices makes application security testing more difficult than ever. Gartner research has determined that the traditional DAST and pen testing tools, which are commonly used to test web-based applications, will struggle in these more automated DevOps-oriented environments. For sure, everyone knows of cybersecurity attacks. Many organizations have significant network security in place, but it's not enough, as 84% of all cyber attacks are happening on the application layer. This graph gives you a breakdown of attacks happening on different categories of applications, and you will notice that microservices and web-based are on top of the list. From this, we can understand why application layer is the number one attack surface for hackers. When we dig deeper into the state of automation used today, the bulk of automation is still in the early part of software development lifecycle. That is mostly when developers commit their code and build their code. As you can see from the graph, the automation level starts to drop from test to production phase. Nearly half of the development teams still run tests manually in test production phases. And guess what? Most of the security vulnerabilities only show up during the test phases. And all of this really compounds the time and effort that's needed to test, troubleshoot, and configure the CI/CD pipeline, not just for non-security bugs, but security bugs as well. This was another study performed by Google last year on the state of DevOps. We see that elite organizations automate and integrate tools more frequently into their tool chains on almost all dimensions. Although automation may be seen as too expensive to implement, automation is truly a sound investment. It allows engineers to spend less time on manual work, thereby freeing up their time to spend on their more important activities. As you can see from this table, security test automation lags across the board. With all the recent attacks and breaches, developers are definitely aware and know security is important, but they don't have the time to spend on it. Developers don't focus on security because they are builders, not breakers. Software development is more a creative endeavor than it's a rigorous engineering process. Developers' primary job is to create features that work, not to worry about what might go wrong. And also, they haven't been trained to do so. Hence, you might find some of these questions on the slide fairly common. But instead of making them change their methods and processes, application security must align and adapt to the development workflows. And that's a better approach. As one of the endless number of acronyms in software security industry, IAST doesn't have much going on for it. It's awkward to pronounce, and it's hard to guess what it stands for. But what is important, of course, is what a string of letters does stand for. And in that case, interactive application security testing has a lot going on for it. It is a tool that is remarkably effective at rooting out potentially catastrophic bugs in web-based applications during software development lifecycle. So what is IAST? Please observe the keywords on the slide. While there are a variety of testing tools and techniques, each useful at different times and in different ways, one of the most effective is IAST, a technique that does its analysis from within the application. It does so by using software instrumentation, by deploying agents, and merely observing the interactions to identify the vulnerabilities in real time while the apps are running. Instrumentation is nothing new. It's already being used in performance monitoring apps like New Relic, Dynatrace, App Dynamics. Some of you must have heard of them. You can think of it like a car dashboard with its instrumentation. It displays all this information in real time while the car is running. without impacting the performance. This way, it's non-intrusive. But before we dive deeper into IaaS, let's look at some of the other tools we have and the differences. Other tools. Yes, that means even more acronyms, which include SAST, Static Application Security Testing, DAST, Dynamic Application Security Testing, and RASP, Runtime Application Security Testing. SAST is the granddaddy of application security testing, and having been in developers' toolbox for more than a decade, it helps developers analyze an application's source code to determine whether the security vulnerabilities exist and to ensure conformance with the internal coding guidelines. DAS technologies are designed to detect conditions that indicate a security vulnerability in running applications. Note the difference from SAST, which tests applications as code, not while it's running. The IaaS technology combines and enhances benefits of SAST and DAST. The accuracy of an IaaS vastly improves that of SAST and DAST because it benefits from the static and runtime points of view. While it's not a complete replacement for DAST or pen testing, it is superior to both for finding vulnerabilities earlier in the SDLC, with, when it is easier, faster, and cheaper to fix them. RASP integrates with an application to prevent attacks at runtime by analyzing traffic and end user behavior. These tools should complement rather than replace your testing strategy. Each AppSec tool have distinct advantages, but you'll get the best results when you use them together. You must be curious. This sounds like a great tool, but how does it really work? Well, at its core, it's based on runtime analysis technology. It means we are able to look at the code as it's running as though we were a debugger. Debugger can stop every line of code in memory and look at things that are happening on the server side. So in IaaS, the agent is doing all the magic through software instrumentation. But what does it really see though? The agent is able to monitor pretty much everything: HTTP requests and responses, calls to the database, the data flows, and configuration information. The tool then shows the reflection of the source code and points out the location of vulnerabilities for developers. Since they are running from within the application, as tools detect vulnerabilities in the running code, whether be it custom code, third-party libraries, or even code generated on the fly by the framework. Let's look at it in action in this animation. The two steps here happen before the user gets a response back from the server. That is immediate results. As you can see, once the agent analyzes the code in memory through software instrumentation with a key focus on security, many of the IaaS tools stop at this step. However, some advanced IaaS solutions can go a step further and replay the original HTTP or HTTPS request with a malicious parameter value and verify that this vulnerability can be exploited. This helps reducing the false positives to nearly zero. If I were to zoom in on the magic that agent performs, here's what it looks like. At its core, it uses instrumentation, which is basically injecting code into the running application without modifying the binaries. On the right, you can see the original code flow, and further right, you can see these little orange blocks. These are nothing but segments of instrumentation code inserted during the instrumentation process. Languages like Java, .NET have an instrumentation API that makes this possible to put these orange code in place. So what we put there are the things that we want to look at and access variables in memories and see what's going on. It's transparent and doesn't have influence on the process, and this way it's non-intrusive. There are actually two types of IAST approaches, active and passive. Both approaches rely on an agent instrumented within the application. Let's have a look at the two methods. The active IAST approach combines a web scanner such as DAST, also known as Inducer, with an agent that sits inside the application server. As you can see in the image, two different components are required to perform the security analysis, the attack component and the detect component. The attack component scans the URLs of the application by sending a list of known attack payloads. This process can be considerably time consuming, and depending on the size of the target application and the number of attack payloads. The detect component, which is IaaS, provides additional context thanks to its visibility of the internal response of the application to the traffic that is generated by the attack component, which is DAST. Active IaaS does not suit fast-paced development environments since DAST requires full compilation upon every code change and can only be used towards the end of the SDLC. Whereas, on the other hand, passive IaaS implementations do not require a secondary inducer to attack because any kind of legitimate traffic is enough to perform the security analysis. Any sort of testing performed on the application, whether automatic or manual, will be leveraged to collect and deliver security issues on the running code in real time. That is why passive IAST is also known as full, and active IAST is known as partial or light. It does not perform attacks and scans to detect vulnerabilities, so active doesn't necessarily equate to better here in this case. IaaS bridges the gaps between SaaS, DAST, and pen testing. You could even say that the IaaS was made for DevSecOps and closely allied SDLC concepts of Agile and CI/CD. Let's find out how. Both traditional static and dynamic testing have limitations that leave a security testing gap in the SDLC, especially for teams adopting CI/CD and DevOps. While SAST can be used early in the SDLC, it doesn't detect many of the real vulnerabilities that only show up during the running of the application. DAST and pen testing are complex and used late in the SDLC and don't integrate very well into the workflow of CI/CD pipelines, making it costly and time consuming to fix vulnerabilities that are found. There is an obvious gap with the traditional tools, and they have their own limitation. IAST addresses this gap by providing a solution that allows for automated testing of web application. with the ability to provide development with the specific location of vulnerabilities in the code. IaaS can be used in all stages of SDLC, but it has most profound impact and return on investment in the development, testing, and QA phases. Any sort of testing performed on the application, whether automatic or manual, functional or non-functional, will be leveraged to collect and deliver security issues on the running code in real time. That's the beauty of it. No additional config or setup. After all, the primary goal of DevSecOps is to have security practices baked into the agile development process rather than delaying testing until just before release. In order to better appreciate the value of IaaS that it brings to the table, let's have a look at some use cases and understand the many distinct advantages over traditional solutions and why it's poised to be the next big thing in the security industry. We have some customers with few problems and they are hoping to resolve. Let's see how IaaS can help them. Well, Michael Scott, the self-proclaimed world's best boss, wants to really help his organization. His organization, like many others, rely exclusively on an external security consultant to perform manual pen testing post-production. The challenge for pen testers is that they have only a brief window to test what is new in any new given release. However, this would result in up to 2 weeks of work for developers and testers to remediate the vulnerabilities, increasing the cost for remediation and slowing down the time to market. This makes the process slow and expensive. With IAST, the developers within the organization can test while they develop. IAST gives a comprehensive look at the entire application and its components once any modification is made. IaaS can be run on demand, so testing is no longer constrained to a brief window before go live. It enables substantial productivity gains versus manual verification by security teams. This results in saving time and money and reduces the reliance on an external security consultant. It's almost like having an automated virtual team of pen testers to identify common security vulnerabilities. Dwight Schrute from the same company has a different focus. The last thing a security or a dev team need is a massive list of potential vulnerabilities that require a lengthy, tedious manual review and triaging. In addition to being accurate, your developers need detailed and contextual information about vulnerabilities and where they are located in the code and how to remediate them. The best IIoT solutions can also automatically verify whether the vulnerabilities they find are exploitable, so developers are less likely to investigate a bug only to come to the irritating conclusion that it is nothing more than a false positive. This saves wasted time resolving false positives, so helps the team focus on real critical vulnerabilities that matter the most. Morris, who is the AppSec head, is worried about the open source risk. With the prevalence of open source code in today's software, effective iOS tools need to be aware of the open source composition of the applications being tested. Some iOS solutions have this feature, giving teams additional insight into vulnerabilities, license type, version numbers of open source components, libraries, and frameworks used in their code. Security auditor Dinesh is keen on ensuring they are compliant with the standards that are important to his organization. This technology identifies vulnerabilities that pose a real threat to critical data, including complex vulnerabilities and logical flaws no other technology can detect. Stealing sensitive data is often the objective of malicious attacks. IaaS is a data-centric solution that is continuously tracking the flow of data across all application tiers and components. It identifies whether the data is mishandled or insecurely stored and exposes potential data leaks before they become a business risk for organizations. This enables sensitive data to be automatically tracked anytime they are saved unencrypted in a log, database, or file. Sensitive data tracking helps organizations achieve compliance like PCI DSS standard or GDPR, etc. Jen Barber wants to make sure this doesn't disrupt the existing process. Developers or DevOps engineers don't have to be security experts or change their normal workflow. No special scans, no extra work required. It's easy to integrate IaaS in CI/CD workflows, custom enterprise-specific tools, and developer tools. It works with virtually any type of test method, existing automation tests, automated web crawler, and a range of pre-production testing from manual test, functional, integrated regression, and user acceptance tests. Plus, it has a flexible deployment model, fully automated, Docker-based, or manual, can be deployed on-prem or in the cloud. Different types of applications are also supported, like microservices, cloud-based, or even standard architecture. So, here are the key takeaways. IaaS has seamless integration. It's easy to integrate and automate in the CI/CD pipeline and even easier to deploy and configure. Plus, it's optimized for security, development, and DevOps teams. When it comes to privacy and compliance, it's the only AppSec testing tool with complete sensitive data tracking. It's, it also has the benefit of integrated software composition analysis for open source dependencies, IaaS ability of accurate findings with real-time verification helps prioritize remediation and in turn helps to empower developers. Lastly, it's designed to scale. It supports large-scale modern application deployments. Keeping all this in mind, IaaS is the only one element of modern application security program. We need a combination of modern solutions such as IaaS and traditional AppSec tools like SaaS, DAST, SCA, pen testing, managed services, and what have you, to create secure software in today's complex development environments. At the end of the day, the simple answer is there is no silver bullet. No single technology or solution can solve the wide variety of application security risks you need to deal with in today's world. To succeed, you need to take a multi layered approach that combines a mix of application security strategy and programs with in house and outsourced testing. If you already have that in place, that's great. But for those of you who don't, Synopsys offers the tools and services to help strengthen your security posture. Investing in automation tools and services from a trusted leader in the AppSec environment could make the difference between success and disaster. With that, we have come to the end. I hope I was able to add value and hope you found this session useful. And I would like to thank you for listening and tuning in. If you have any questions, please feel free to ask them now.
Hey guys, yeah, I think I just saw a couple of questions in the Q&A. I'll just answer one that just came up. So in terms of maturity, right, it really depends on your objective or what type of software development and delivery framework you have in place. If you're just starting out with application security in your organization, even if you're starting on a small scale, IAST can give you a lot of value and can give you the best bang for your buck because it has these additional capabilities of detecting open source software as well and the value that you have seen, right, based on the case studies. Apart from that, um, I see another question come in, which is deploy RASP solution if we have asked. If you want to follow a more proactive defensive approach where you want to block those attacks, then possibly you might want to. But really depends on what approach you want to go for, whether you just want to detect the attacks or really go full force and block them. That's prone to false positive as well, and RASP also has certain performance issues. So you might want to take that into account and factor that in as well. Um, yeah, so do I have any stats around the time added during the development? That is something that which we can provide to you. We might have that for you. I don't have it on top of my head right now, but definitely you can visit our booth as well, at the Synopsys booth at Sponsor Hub Level 1, and I can take that question up there. Um, Also, for the slides, yes, feel free to again visit our booth, or even Simon has just dropped in his email, and you can even email him, and he should be able to provide that to you all. I guess those are the questions that have just come in, but thanks for joining. I hope you enjoyed the session, and if you think of anything else and you're curious, please feel free to come to the booth or even chat um, on this option here. Thanks for your time, guys.
Thank you very much for that, Ronald. Next up, we've got Barry McMahon from Log Me In talking about the value of identity in the digital environment. So that should start in a couple of minutes' time. We'll see you all then.